All right, pre-calc students, in this video we're going to be writing a polynomial function of minimum degree in standard form with real coefficients whose zeros include these particular things right here. So I got a zero of -3, 3 minus I, and 2 plus 5i. Now, by the complex conjugate zeros theorem, if we're told that if a and b are real numbers with b not being 0 and a plus bi is a 0 of f of x, then its complex conjugate, a minus bi, is also a 0 of f of x. So what that means to us is that when we're given problems like this, if I see that 3 minus I is a 0 of a function, that means that its complex conjugate, 3 plus I, is also a 0, and it wouldn't have to be listed. Okay, same thing with 2 plus 5i. If 2 plus 5i is a 0, then so is 2 minus 5i. So I have to know that going into this problem where I'm going to write a polynomial function. That means I'm going to FOIL some things together and come up with factors, FOIL them together, clean it up. Before I do that, I have to know what all the zeros would be. So I've got a 0 of -3, that's great. I've got both of these complex zeros and both of these complex zeros. Now once I know what the zeros are, I'm going to turn the zeros into factors. I'll show you what that looks like. So if -3 is a 0, that means that x plus 3 is the factor that it comes from. Okay, -3 would make that equal 0. Now with the complex ones, it's a little bit trickier. So I've got, we'll go with red for that one. If 3 minus I is a 0, I'm going to go with this, x minus, and put it in parentheses, 3 minus I. So I treat it as if it was a single number, okay? X minus -3 turns into x plus 3. So x minus 3 minus I will turn into, whatever it is that I simplify it to. So that's one of my factors. Now for the complex conjugate, 3 plus I, I'm going to do the same thing. I'm going to take x minus parentheses 3 plus I. Okay, close those parentheses, close the brackets. Now, I'll come back in a second. If I have these two zeros here, when I write out those factors, I would have, I want you to watch how I write this. I'm going to write it a little bit differently. So I'm going to take x minus 2, and I'm going to know that I'm going to subtract 2 and 5i. So instead of writing the parentheses, I'm going to save myself a little bit of time and a little bit of ink. And I'm going to say x minus 2 minus 5i. So that was me distributing the negative sign to both of those terms without having to write it out. Okay. Then if I did the second one, x minus 2 minus 5i, maybe you can guess what that would look like. It's going to be x minus 2 plus 5i. So I distribute the negative sign to both of those. That's what I come up with. Okay. Now, I could have done that to these in red, but again, if you're new to this, I would do this step to make sure I don't screw up any negative signs or things like that. So at this point, with the two expressions in the red, then I'll distribute the negative signs, and I'll have x minus 3 plus I for one factor, and then I'll have x minus 3 minus I for the other factor. Okay? Now I'm going to FOIL all these things together. Now the key to doing this is you're going to FOIL the factors that have the complex zeros first. So I'm going to FOIL the things in red first, then I'll FOIL the things in blue, then I'll deal with this x plus 3 a little bit later on. The idea is when I FOIL the two expressions in red or the two expressions in blue, that I term, an imaginary unit, it's going to go away. And I'm going to be left with just a polynomial that doesn't have any imaginary numbers within it. Okay? I'm going to show you how I would do that with the two in red first. So essentially I've got three terms. That's kind of how I'm going to treat it. So I'm going to start by distributing the first term, x, to all three of these other terms. So I'm going to have x squared minus 3x minus xi. Now what order you write those in, ix, xi, doesn't really matter. I like to put the x's first and the i's second. Then I'll take the -3 and distribute it to all three terms. So that's going to give me -3x plus 9 plus 3i. Okay, now again, I know it's weird to have I terms, that's okay, and just trust me, they're going to go away eventually. Finally, I'll take I and distribute it. So I is going to go mean all three of these guys. So we're going to have a plus xi and a minus 3i and a minus I squared. Now, a couple things about this. First of all, I squared, right over here, is equal to -1. So I always replace I squared with -1. So this goes from being the opposite of I squared to being the opposite of -1, which means really I'm going to have +1 at the end. Okay, that's what this is going to turn into, is +1. Now other things that are happening. I notice that I've got x squared. It doesn't have any like terms, so I'm going to say that x squared is going to be part of my final result here. And then notice that I underlined to say, hey, I worked with this. Negative 3x has a like term of another negative 3x. Negative 3 and negative 3 make for negative 6. So negative 6x. Then negative xi, I look for another one. Oh, I got a positive xi here. So negative xi, positive xi are 0, so those are going to cancel each other out. Next term that's hanging around is this 9. I'll take 9. Any like terms there? Oh yeah, the positive 1 that was at the end. So I'm going to have a plus 10 attached to the end of this. Then positive 3i has the only like term left is negative 3i. Positive 3i, negative 3i are going to equal 0, so those are going to cancel each other as well. So x squared minus 6x plus 10 would be the polynomial product of these two factors here. Okay. Now I'm going to do the same thing with the expressions that are in blue. Give me a moment to clear a little bit of space. Okay. So in blue, when I FOIL, I'll do this a little bit quicker. I'm going to take x times that, all three. So I got x squared minus 2x plus 5xi. Okay, that was distributing x. Then I've got negative 2x minus 4 minus 10i. So that's distributing the negative 2. And then I'm going to distribute the negative 5i, so it's going to be negative 5xi plus 10i. And then I got minus 25i squared. Okay, so as I put these things together now, we'll go with blue and we'll do. So x squared is going to be its own thing. That's great. And then I've got negative 2x goes with negative 2x. That's going to be negative 4x. That's nice. Positive 5xi, negative 5xi are going to cancel. That's convenient. I got a negative 4. The like term is way at the end here. So negative 25i squared. Remember, I squared is negative 1. Negative 1 and negative 25 multiply together become positive 25. So if this is positive 25, I'm going to take that and add it to this negative 4 that I have here. And that's going to be plus 21. Okay. Actually, that should be a positive 4 right there. I messed that up. It was negative 2 times negative 2. That's positive 4. Okay. So positive 4 and positive 25 makes for 29. My apologies. Negative 10i plus 10i cancels, becomes 0. So there I've used all the terms. I've multiplied them together, which is nice. So don't forget about this x plus 3. It's still there. A lot of work going on here. Okay. But once I got to this point now, I'm going to let you finish this off because after this, it's simply a matter of foiling. I would probably do red times blue. You could do green times red and then take that times blue. It doesn't really matter. Whichever order you do it, it's just an awful, awful lot of FOIL. And let me give you the correct answer here so that you know what you should be shooting for if you're going to finish this one off. So when you're all done, what you want as an answer for this one is going to be x to the 5th minus 7x to the 4th plus 33x cubed. 33x cubed minus 25x squared minus 352x plus 870. Plus 870. It's a pretty big deal, pretty big number going on here. Okay, so it's a plus. So this is what you should end up with when you're all done foiling that whole thing together. So good luck with that. Great practice. We'll see you.